Learn with Duop.
Mala. Welcome back to Learn with Duop. I hope Malpenkun over here. They going to dial content, they in both in dial content. So while it's been chapter 2, nung biology remedial. So media remedial, Missy video, me just cooking subscribe, which you subscribe. Commission subscribe, which you share and gun more on a channel on man. Tin can you jack you later along, coach, I live with Pelping. Committee the more, Metaka school, be a larabo, ko da channel on what I haven't joined. Ko can biology do no man. The same kan biology into kon goro gomi okay so wala man right kajen chapter 2 me biochemical molecule okay so chapter me jeje me bana da kreo okay bana moy pandaro ka par nem bana organic molecule bana which so the organic molecule ro bana carbohydrate ke lipid ke protein so bana kenen okay so ka patu bana nucleic acid bana even which okay kan inorganic molecule ka patu so without further ado let's get started okay so everything we want is made of atom an atom money a very tiny okay kui along chada nen ko wanga chada lel ko so very tiny is also hard to understand okay so an atom money a basic unit of matter okay a basic unit of matter so an atom money is made up of smallest particles okay particle titi long so particle raw to proton then neutron electron so kan particle rene kan ngula kan ko atom kan ko magabana okay so kan ko magabana so an atom point take a central nucleus okay and central nucleus is made up of proton and neutron okay then ko electron ko electron okay ko electron proton and a positive charge neutron and neutral the charge electron a negatively charge okay a negatively charge therefore an atom okay electron lose ke gain ba chol ion okay ba chol ion so atom electron lose ba chol ni mon ba chol cation okay atom electron gain ba chol an ion okay so ba chol an ion so kan atom dream ga combine ke ka mat bi mu lel bi element bi no okay bi element bi no so element mu a pure substance okay a pure substance mitel ka mat okay then element mo kay quite made up of mu made up of muta made up of the same atom okay made up of the same type of atom okay made up of the same type of atom for example hydrogen carbon oxygen and nitrogen so the chere can ka element okay and this element they are made up of the same type of atom okay they are pure substance okay they are pure substance chico component okay molecules sometimes they made up of the same kind of atom key different kind of atom okay for example so oxygen molecule is made up of it is made up of two atom of oxygen okay two atom of oxygen so water molecule is made up of different type of atom the atom of hydrogen and atom of oxygen okay an atom of oxygen so all living organism we they require more they require several compound okay ko be equal to tega okay kan compound ra chol kon ke biomolecule okay key molecule of life so bio ngi kon life the molecule gen molecule so can compound ra chol kon the molecule of life okay key biomolecule so when biomolecule they are made up of a small unit called element okay so element ni mi cha combine bi ko ngulel bi ke molecule bi kan no okay bi kan molecule bi kan no so scientists ni chike element here over 109 chicken ngale chicken can discover okay chicken discover pre element 109 to 103 radian kan ngai ke gwana kan ngai ke lo den gwana so ray 103 to element da well radian ke important the tick ray we mon to content ke important the tick ko even tick even maintain okay so radian kan element da well ta element da makel are very important okay kan element da makel they are the main building block of cell okay they are main building block of cell because ko di la kan vine chemically ko bikin mulel ko bikin cell bikin mo unique structure okay ka bikin ja ko be internal activity ni kon tin ko cell ko karawat bikin lele bikin control okay ba control kan element da makel to carbon ka hydrogen ka nitrogen ka oxygen ka phosphorus ka sulfur okay tangon ndi ka remember sponge element okay sponge element so kan element they are very important kan living thing te kan element dang bakelti okay te kan element dang bakelti radiant kan element raw the most abundant okay ten gagalong ten one long ka living organism kamu hydrogen ka carbon ka oxygen then ka nitrogen so kan element they ka remember chon, okay? They can remember chon. They are the most abundant element in living organism, okay? In living organism. Can elementary, they are very important biologically. Ko diri ko misika vine, okay? Misika vine. Ki misika react ke anador. Like a strong covalent bond, like an allele, like an form, okay? And a strong covalent bond more very stable, okay? Very stable. Chedamal break, okay? Ko chedamal break and stability money jaga ka ko di ngon molel ta kan molecule to content tin very complex bukan ka form, okay? Circa protein ke DNA ke lipid. So kan molecule ri ke very complex, okay? They are made up of so many molecules, okay? So ko no goro bi bone dan mo ko molecule ro ko bind but di ta ba very strong, okay? Ka ko elementary ta kan couple strong covalent bone la kana form. Joje ko mo ke very important, okay? Ke very important. So mi ba kon ko organic molecule kan molecule in content mo then they are made up of carbon, okay? They are carbon based compound, okay? They are carbon based compound. Kan organic molecule they are found in living organism, okay? They are found in living organism. Usually kan attack carbon muku bind ko ka hydrogen ke oxygen ke nitrogen ke phosphorus ke sulfur sometime. So kan organic molecule they are formed michi small unit one michi kultare michi kula join, okay? Bukan mulel bukan long chain bukan kula no, okay? So one product ko element rock ke small unit rock ko join ke jamone chuala synthesis, okay? Synthesis tere wol ren dor ke malar kan dor, okay? But ke reaction mane ko la water ko ja remove ba chual dehydration synthesis, okay? Dehydration synthesis reaction, okay? So major class of organic molecule are carbohydrate, protein, lipid, and nucleic acid. So kajan topic wala mane bana wini kan anjo koti bana nucleic acid bana which kachang dong, okay? Kachang dong. So mi kon mana carbohydrate kan carbohydrate ne ka substance netin content tin kwa mega bungu element like carbon, hydrogen, oxygen kakan teacher kan second ga general formula CH2OY, okay? Where y kan yak to ke variable number, okay? That kan number mana ni chilatin. So kan kan y mon kan ku ngolelo ne kan ku structure dung carbohydrate ku le ku yo determine yo ko dong ba da yak da 1 da 3 da 4 da ngo ko nyam, okay? Ko nyam. So carbohydrate literally meaning of the term low hydrated carbon, okay? Hydrated carbon plasma plus water, okay? Plus water ko di ratio dan ko hydrogen kan oxygen ko present ke carbohydrate again the same ratio no ko present ko water ko ratio 2 to 1 ratio, okay? Hydrogen daro kan oxygen kel, okay? Kan oxygen kel. So chen chwa kwala cholo carbohydrate, okay? Carbon plus water, okay? So kan carbohydrate they are good energy source for living organism, okay? So their function along mainly for energy, okay? For energy. Therefore, very good source for energy. There mo cell go in large amount, okay? Go cell in large amount. Ko cell take activity one ko kare. Or can activity raw go energy, okay? Ko carbohydrate good energy source. Gor cell in large amount, okay? Gor cell large amount. Carbohydrate can be aldehyde ki ketone, okay? Aldehyde katen kono take carbonyl group kamuta kn of the carbon chain, okay? Kn of the carbon chain taken ga general formula RCHO, okay? So in carbonyl group mone la take muta kn of the carbon chain, okay? Kn of the carbon chain. So ketone group katen kono take ketone mo and take ketone functional group, okay? Ten kono take carbonyl group meta within der carbon chain, okay? Taken ga formula COR where are many variable number, okay? Okay, variable number. So example of aldehyde cherry glucose, example of ketone cherry fructose, okay? Cherry fructose. So can carbohydrate rin so alga didi taken get several hydroxyl group, okay? Several hydroxyl group. Then a hydroxyl group money then could their chemistry ku jung lelita ku ede sermanya ne no tribi ke react didi ke use then muta then hydroxyl group mo then ku ede sermanya, okay? Then be ku ede try man. So carbohydrate can be divided into three main class, okay? Into three main class depending on the number of sugar. the corner tag, okay, the monosaccharide tin corner tag sugar unit, 1 sugar unit, the disaccharide tin the 2 sugar unit, the polysaccharide tin content sugar unit 1 join together, okay, then sugar 1 join together. So monosaccharide single unit, single sugar unit, okay, single, they are made of single sugar unit, okay. So general formula CH2ON, okay, CH2ON. So the common monosaccharide glucose, fructose, galactose, okay. So the chicken get carbon. The content that take truth to take 3 carbon. The content to all fentose to take 5 carbon, okay. The 5 carbon. But the common is long kajan monosaccharide glucose, okay. Glucose de la beta common. Glucose is very important. Ko do to one ko take a function to one. Jela source of energy long mostly, okay. Ko jela source of energy one important ka brain cell ka cell to on the brain and gorkan glucose in large amount ko work long gorkan energy, okay. Therefore a very important go da brain cell, okay. So a very important bakola plan like green plan like an let and glucose with a sunlight, okay. So we can like can plan yo michigan la baban jegala baban chamala pudumuta animal to kong chia kon kana lady kong, okay, chia kon kana lady kong. However in glucose goro reka vlat ba mla chwala constant level of glucose ba le diri ba maintain ko body ba ko function of gwa, okay. Ko mi di long ka reka vlat ba jek ka mi ko long ka vlat then ba jek. So ko body function ba ko gwa ba constant level lamu glucose ba le ba maintain, okay, ba maintain. So glucose ba very important ko ira as fuel ka release energy for cellular activity, okay. So ka any activity mila cell ke lu then glucose la as a fuel on then la jabo man ba la dial ro ba la ke ka cellular respiration then glucose la ko breakdown ko ba ngolel ko ba ATP ba la, okay. Then glucose la ko la ko ba ATP ba la nyok bana ka jen cellular respiration ba ko ba ATP ba la bo goro glucose ba ke nyamba, okay, goro energy ko no very important ko aga sungu as a fuel, okay, as a fuel. And glucose will like store liver ke ka muscle, okay, animal we can store there ko whenever mishi body you go we can banya okane and glucose mone baban yo lele baban yo reduce, okay, baban yo reduce, okay, baban yo reduce la store as staging in plan, okay, in plan, okay. Ka important ba ko cellulose ko form, okay. Cellulose mane structural support ko provide ko ka plan, okay, ka plan. So kan all monosaccharide reducing sugar, okay, ka reducing sugar ko di ta kan ga pre-aldehyde group, okay, ta kan pre-aldehyde group and pre-aldehyde group mane miss react ka reagent and reagent la ko electron la ko donate, okay, miss electron mo miss donate be reagent mo be reduce, okay, be reduce ko na chwal ke didi chwal ke reducing sugar, okay, chwal ke reducing sugar. So la kan reagent like benedict ke failing mane la kan reduce, okay, la kan reduce. For example whenever we go ko ba test whether take reducing sugar wal tele reducing sugar la mi wala benedict test and failing test la ka use ka, okay, failing test. So ka benedict test go mane reducing sugar mi jar big ria mi ria kan ko cover be electron be donate to cover, okay, be cover be reduce into cover plus, okay, be reduce into cover plus. So mi reduce yo be big red precipitate be lidi be form, okay, be form, okay. So therefore mi benedict solution mi test whenever mi take muta mete ke reducing sugar be color bango ba bricks red, okay, bricks red precipitate. So ka failing test go amene o me ci reducing sugar me ci react kane copper be reduce ka be ke red copper oxide precipitate mane be leliri be kane form, okay, be kane form. So chwala ke reducing sugar kodi ko wana bar me ci react reagent akan reagent amona akan reduce kodi ko taken aldehyde group ke pre aldehyde group mula electron mula ja donate, okay, mula electron mula donate. Tabi kong nyen carbohydrate ke disaccharide, okay, ke disaccharide they are formed in two monosaccharide which been together which bind together because disaccharide become form, okay. Usually can to kon laba together exos, okay, exos ke exos na check meta glucose ke fructose ke galactose, okay, ke galactose. So which bind together being mulel ba cholo condensation reaction ko ba water ba remove, okay, ko ba water ba remove. But the bone dan man ko monosaccharide ro mo ko mat ke me yen ke chwala glycosidic bone, okay, glycosidic bone. okay. So an process money but that or repeat mana bangulela ba molecule mi dir baler which is polysaccharide, okay. So the most common disaccharide are maltose ke lactose ke sucrose, okay. Maltose la be mi glucose ndara mi combine ke mi mat lactose mi glucose kan galactose mi mat, okay. Sucrose glucose plus fructose, okay. Plus fructose radiant kan 3 maltose kan lactose kamu ke reduce sukare but sucrose mu ana reduce sukar, okay. Ana reduce sukar. So type dong ka carbohydrate e polysaccharide, okay. Polysaccharide mene ke polymer of many monosaccharide, okay. Monosaccharide ngwalong big combine together big molen big polysaccharide big clone. Some of the polysaccharide men nam glycogen. So glycogen mene energy storage animal, okay. Energy storage animal. Ka glycogen mene highly brine, okay. Highly brine. Ta dana ku monosaccharide ku ro ke na ren ke ta ke brine, okay. Ta ke brine. Ka bona dana pom poinken pom kam ni ken mutual alpha 1 4 kana alpha 1 6 glycosidic bond, okay. Glycosidic bond. So mi yena gu yena gwama ta carbon number 4 kana carbon number 1 dung glucose na mane bika bany, okay. And bond ba pom kam ni ba chol alpha 1 4, okay. Alpha 1 4. So ka brine dong meta mi brine gwama ta carbon number 6 ka glucose me kana carbon number 1 ka glucose dong mane. So bond ba chol alpha 1 6 glycosidic bond. Alpha 1 codita is made up of alpha glucose, okay. Alpha glucose ko no bond ta kam ni alpha 1 4 kana alpha 1 6 glycosidic bond. So polysaccharide dong is starch, okay. Starch mene energy storage in plant, okay. Energy storage in plant. So in starch take two type take mana chola amylose kana amylopectin, okay. Amylose kana amylopectin. So one many time ka amylose and brine, okay, which is a straight chain, okay. A linear tele brine ko tele brine alpha 1 4 glycosidic bond mana na ku ngulelda min ku kan oxygen kan glucose ro ko bind together ko tele brine, okay. Chat kan gu yen gwam ni ta jan carbon number 4 kan carbon 1 mene kan be banyo no be together ba chola alpha 1 glycosidic bond, okay. Alpha 1 4, okay. Ba chola alpha 1 4 glycosidic bond. So ka ma dong ma nyok bi jen number 4 carbon number 4 kan carbon number 1 ka glucose dong kan bi nyaw ban no tele brine jan 1 kan 4 1 kan 4 carbon number 4 kan carbon number 1 kan banyo na. So no man chwala mu chwala amylose, okay. And brine bond dan da kam den alpha 1 4 glycosidic bond. So type of study dong amylopectin, okay. Amylopectin. So ana amylopectin mene a branch, okay. A brine, okay. So ka bond dan chet kama nan ko chet kama ko ne jagwam glycogen bond dan ko po ma alpha 1 4 kan alpha 1 6 glycosidic bond, okay. Glycosidic bond chet kama ko ne ngwa mane. So bi carbon number 1 kan carbon number 4 ko glucose bi mat ka brine de yo carbon number 1 kan carbon number 6 glucose dong wan big bang, okay. No ba chola bono da kam number 1 kana no se kana ba chola alpha 1 6 be bono da kam number 1 kana 4 na ba chola alpha 1 4 glycosidic bond, okay. Glycosidic bond. So function ni energy storage, okay. Kamu kana more I mean ka plan, okay. Ka plan glycogen and starch they are convenient storage molecule, okay, because they their large side dan ta ko make make more or less insoluble jaga ko chicken be soluble ko muta ka water ko muka soluble ka water daga dissolve, right, daga ten use, okay. But ko dirkan, okay, ko dirkan side en mona jaga ko bukan muta bukan less soluble ko ka less soluble tel ka muta tel ko osmotic effect, okay. Tel ko osmotic effect chicken be dissolve, okay. Therefore because until chaga goro ba reduce energy manani atogwa ma ba ko reduce, okay. Ba ko reduce. So polysaccharide on a cellulose, okay. Cellulose mane and branch, okay, a linear, okay. But glucose ko form a beta glucose, okay. But can the content to the alguamani starch can a glycogen glucose ko form alpha glucose or alpha glucose. But the cellulose a beta glucose, okay, a beta glucose. So and brandian and bondian basically kel no bas gwalo na me beta ni mingu alpha, okay. So and bond na ta men kam glucose ten ko cellulose kuja mega tango beta 1 4 glycosidic bond, okay. Glycosidic bond. So pumpkin and cellulose structural support ko muta ka plan, okay. Ka plan polysaccharide dong mutual chitin, okay. Chitin mane dung exoskeletal kan fungal wall, okay, ko ngu mo ka structural support ki strength ki protection, okay, madong peptidoglycan, okay, ki more en mane ko provide ko rigidity kan support ko ngota ka bacterial cell wall jan jak bacterial cell wall ko bumone ko protect kan madong da bacteria da otana, okay, mada bacteria da otana, so tron kan carbohydrate, okay, kan carbohydrate. So type of organic molecule dong lipid, okay, a lipid. So lipid organic molecule who consists of carbon, hydrogen, oxygen. Also tangwan lagan tagamu sulfur kana phosphorus, okay, phosphorus. But gwa lipid and proportion manan ko oxygen kana hydrogen ko present kaja lipid. Siga the same kan ta nan ta ka carbohydrate kon jaga 2 to 1 ratio. The oxygen be hydrogen by 2 oxygen by 1, but guamani lipid mostly long oxygen is very small, okay, quite long, okay, quite long in proportion, okay, for proportion dini hydrogen. So the most common form of lipid triglyceride, okay, triglyceride. They are made up of mainly 3 fatty acid be mitichi bind 1 glycerol, okay, one glycerol. And bond under cambian can fatty acid ni kan glycerol chwala ester bond, okay, chwala ester bond. So fatty acid take a saturated fatty acid can saturated fatty acid. Saturated fatty acid can acid the double bond, okay, because they are straight, okay, they are straight chain. So most of the time they are solid at room temperature, okay, can saturated fatty acid. Unsaturated fatty acid can go on take one or more double bond, okay, kan the tiang, okay, take a double bond. They are not well bonded, okay, tagan ka double bond, okay, tagan ka double bond, okay, ko tagan ka double bond tagan mutual king chain, okay, king structure mulono kan chik gwang, okay, chika gwang kan ngono da kan saturated parasine and structure ente mi gwang tan, okay, taga mi gwang tan, therefore ko te mi gwang tan chaka jaga ko begin liquid at room temperature, okay, mulono the more unsaturated parasite get the more liquid, okay, the more by liquid, okay. So liquid mostly they are insoluble in water, okay, chicken dissolve water, ko chicken dissolve water like hydrophobic, okay, hydro no water phobic lo fear, okay, lo fear look and few, okay, look and few, but they dissolve in organic solvent such as ethanol k ester, okay, k ester ko dissolve in the they are of two types can lipid, okay, tem part can oil part is solid at room temperature check meta butter, okay, oil a liquid at room temperature check oil, okay, check oil. So functionally and lipid provide long term, okay, it provide long term energy, okay, it provide long term energy. So tangwane mecha kan chankini midata ka cornini and triglyceride mene that point is bring yok they use ka gwa glucose kon je ganen mu jin energy kan of cell jen use cell long tangwane but that time da kan kin glucose kin jakchi amiti tagara miti ka fasting sinimit that triglyceride mene de wele that your body use that will use like energy, okay, no and lipid very important long term energy, okay, long term energy. So manong they form cell membrane, okay, cell membrane and organelle boundaries, okay, cerke lakana ling cell membrane is made of phospholipid and phospholipid a lipid, okay, a lipid, okay, lipid mane cholesterol to kon tung wan to kon ta di ka jen cell membrane kon ko ke lipid ne kono they form cell membrane, okay, they form cell membrane important, okay, can but they have hormone, okay, or messenger, okay, hormone check steroid hormone, okay, steroid hormone kan hormone ke chemical messenger, okay, ke chemical messenger kono ke very important ko they have as hormone, okay, hormone kan kon ku tung message ngwan ko carry re point nan kan namne, okay, kan namne manong they prevent water loss in plant and animal, okay, for example take mutual wax mone la take leaf plant leaf, so la gango be plant we can feed one we can lose, okay, gango we can feed one we can lose and lipid ba ko loko be vitamin content fat soluble bioable vitamin we can observe, okay, it always absorption of fat soluble vitamin check vitamin A, vitamin D, vitamin E, vitamin K kono they are very important, okay, they are very important. Biomolecule dong mutual protein, okay, protein they are made of of many amino acid. Okay, many amino acid which bind together become protein become gluon. And bone and ko form chwalo peptide bond. Okay, chwalo peptide bond. There are more than 170. Okay, more than 170 amino acid tang right now. But can amino acid draw 20 of them can in kono then ko in ball ko muta ka protein. Okay, then ko ball ka protein. So each amino acid take a for main part. Okay, take a for a main part to go attack you central carbon. Okay, then take a central carbon one bany can amino group. Okay, amino group can move can carbonyl group ka R group. Okay, ke hydrogen. Okay, ka hydrogen to talk and chen one three biga bany ko biga bany ke carbon. Okay, biga bany ke carbon. So another group money jen ba amino acid bi ko ja take a different. Okay, jen ba amino acid bi ko ja take different. So an amino acid divide mainly into two types. Okay, take essential amino acid can an non-essential amino acid. So essential amino acid draw ka acid ko na daran inject you kwan. Okay, ko ni chame. Okay, jen ko na la ju ka daran mi ko take protein on ko kan amino acid draw ci point ko longa lane ci point ko let. Okay, ci point ko let non-essential amino acid ka acid ko ka amino acid ko di je ka da point ko lat yan karo ada kin ga jam telo ko ni jam again. So da point ko lat. Okay, da point ko lat. So protein contain C, carbon, hydrogen, oxygen, and sometimes sulfur. Okay, and sometimes sulfur. Pag amino acid ni tin kon ci bañ kan jam muta kan jak protein ko kat take different. Okay, from each other ko protein no bana protein bana bane pag muta pag amino acid ko na tade tin ci bañ together. Okay, tin ci bañ together. So in living cell, however, kan amino acid can tin bañ ba jalel muta la determine DNA. So bana jak mi ci kono ko muta ka protein synthesis. Okay, ka protein synthesis. So anu protein mat bal hadona la alarmo la determine DNA. Okay, la determine DNA. But kan protein no biga taga different ngu ko different muta kapag amino acid te tade tin ci bañ. Okay, tin ci bañ. Okay, tin ci bañ. So there are four structure of protein tamu chola primary structure tan. So primary structure man simple as sequence of amino acid. Okay, amino acid mutu wan mishi ga bañ na sequence ni mo ba chola muta ba chola primary structure. Okay, ke polypeptide chain. Okay, manong secondary structure. The secondary structure mo wo kan amino acid draw and polypeptide chain ma cha form ka jen sequence of amino acid draw mi cho full. Okay, mi cho full ke cho twist lo che let che ro read in various many way. Okay, and mo be lel ba alpha helix ke beta sheet be form. Okay, ba alpha helix ke beta sheet be form. So one money yo ba cho secondary structure. Then take a tertiary structure. Tertiary structure mo wo kan polypeptide kon de chro ken pull ke chro ken twist mi chi ro ken yo ko wa mat chi ro ken pull ko do dong 3D dimension bi ngulel ba ga cholo tertiary structure. Okay, so tertiary structure simple 3D pull de mo of single polypeptide chain. Okay, cherke kan beta chain de da mis dor cho full cho ro lo le la dong ba cholo ba tertiary structure. Okay, ba tertiary structure. Quaternary structure wo mi multiple polypeptide chain mi chi ro ken ulele mi chi ro ken combine chi ro ken mat chi ro ken arrange together. Then big ulele big quaternary structure kan ulele. The common example of quaternary structure hemoglobin. Okay, hemoglobin. So function of protein they provide support and shape to cell and tissue. Okay, who can support can cell shape who can lele who can provide. Okay, to tissue. Okay, can but the agas but biological catalyst. Okay, kala enzyme most of the enzyme ka protein. Okay, ka protein. So they speed up reaction. Okay, like a reaction like an speed up ko react. Okay, they carry molecule across membrane. Okay, or in the blood. Hemoglobin la carry la kwe oxygen kwe lele kwe carry in blood. Okay, kan ka cell membrane ta tang wana ti sia pass through cell membrane. Okay, so kan te chere kan ro la kan pass through ngota with the protein channel. Okay, with protein channel bana wajak mo kono ka membrane. Okay, ka cell membrane ka cell biology. Okay, ka chapa cell. So kan protein but they serve as chemical messenger. Okay, they serve as chemical messenger ka kan bonan la kan bor la kan defend against pathogen. Okay, again pathogen. So kan ke very important kan protein ka very important. So thank you very much. Then end of our chapter part 1 morning. So let the long coach with this part. so mede me kan loy do be chu ti ko ma sa kin wa mo ko dong ka pa tu dan mi de o mare na mo ma kan loy mo. Thank you very much ko shi alep be ta mal. Bye.